Right, let's talk about VibeEval. I think this is the first paper that has the word vibes in it. So this is not really a scientific paper, it's a technical report, but I'm really glad it's open. It's very cool. And if you want to become an LLM sommelier, then this is definitely a paper for you. So what problem are they solving? Well, they're solving the problem of how difficult it is to understand relative strengths and weaknesses of different large language models, specifically multimodal language models. Every time a new model comes out, lots of people need to spend a lot of time, a lot of effort trying to understand what different models are good and bad at. And there are some ways of comparing different models. So, for example, the LMSys arena is great. It gives us relative sort of ranking of different models, but it doesn't give us this granular understanding because some models might be better at some tasks and worse at other tasks, and vice versa. So this paper is contributing a data set that makes it easier to do this kind of evaluation, and also a procedure for doing this evaluation. I really like the data set, and I'm a little skeptical about the procedure, but we'll get to that. So the way the dataset looks like is they have 269 examples, where each example is an image, a text prompt, and a gold standard answer. So 269 examples is not a lot, but it's very high quality data. All of that has been created by authors and verified through multiple rounds. And it's also divided into two parts, the normal and hard set. And the hard set is interesting because these are the problems that current best models, or the frontier models, are not dealing with very well. They solve about 50% of those cases. And there's this interesting chart where they show this Goldilocks zone. So this is where the hard examples currently are. Obviously, as the models improve, they will start answering this correctly. So we'll need to get new examples, and they're promised to keep doing that, to kind of expanding the data set with time, so that we can get this useful set of examples that shows the differences between models. So I like that. It's kind of a cool idea. So then, given this data set, they can run it. Given the data set and a new model to evaluate, they can run it. They can run the model and each example. So given an image and a prompt, what answer does this particular model produce? And then they have to compare this answer to the gold standard. And that is tricky. Obviously, a human can do it. And they run an experiment where they ask humans to rank how similar the model answer is to the gold standard answer. And that works, but obviously that doesn't scale very well. So the other thing they did is they asked their own model. So Rika, the authors of the paper, their company, and they have their own model behind an API. The API is available, so they can ask their model, given this answer and that answer, how similar are these two answers? And the model gives us a ranking between 1 and 5, and that gives us a way to score. Obviously, the question is, how good is the model at scoring the similarity? So they run the study to compare the human rankings to the model rankings, and they found rough correlation. So it's not perfect. And for example, the LLM evaluator is a little more generous with its rankings than human evaluators, but they found that there is rough correlation. So models that do well as evaluated by the LLM will tend to do well as evaluated by humans, even though the correlation is not perfect. So kind of interesting. I'm a little skeptical about this for a bunch of reasons. So there is, for example, they have the sentence that in some instances we had to refine the prompts and responses only after qualitatively inspecting the evaluator's explanations for its rankings. And so basically realized that the evaluator misunderstood some question or some answers, so they didn't evaluate it correctly. So they tweaked the phrasing until the evaluator got it right. So it's fine. Like on that data set, it works, but it doesn't mean that this method is generalizes to other situations. And they also found that they also ran the sort of evaluation on sort of normal group of crowdsourced humans and on experts, and the experts kind of trashed every model except the very best models, so Gemini and GPT-4. And that's kind of interesting. I think that also is a little, maybe not a disproving, but it makes it a little bit sort of interesting how the other ranking methods are, faring against these expert rankers. But nevertheless, I think it's a really cool paper, and it's worth going through the data set. So thanks.